Morning, sir. My name is Sainath Reddy. Today, my topic is assigning assigning array to another array, dynamic changes of an array size. Introduction to arrays. Arrays are data structures that store multiple values of the same type. They offer efficient way to manage collections of data in programming. Understanding arrays is fundamental for efficient programming and data manipulation. Here is a simple image of array implementation. Differences between Java length and the Java length method or Java length properties. In Java length methods, there are primarily used by the string class, must have round brackets at the end, syntax, string variable dot length, semicolon, return the number of characters in a string. The length cannot be resolved, compile error can occur on misuse. In Java length properties used by Java arrays, must have not round brackets at the end. Syntax array variable length returns the size of capacity of an array. They cannot be invoked length and a attribute compile error can occur or misuse. Java array size and length. Here the most important concept developers must know when the size Java arrays and deals with the Java arrays length. The theoretical maximum Java array size is 2 crores, 1,47,000. To find the size of the Java arrays, query an array length properties. The Java array size is set permanently when the array is initialized. The size of length cannot be array in Java includes both null and non-null characters. Unlike the string and array list, Java arrays do not have a size or method only length properties. Assigning one array to another. In many programming languages, you can assign one array to another directly. This assignment often means copying the reference rather than the actual data. Consequently, changes to one array may affect the others, leading to uninitialized flight effects. Before before assigning operators, array 2 is equal to array 1. Array array 1 elements of array 1 uh, equals to array 2 elements of array 2. After using of assigning operator, array 2 is equal to array 1. Here both array 1 array 2 equals to array 1. Swallow copy versus deep copy. A swallow copy creates a new array but only copies reference to the original elements. A deep copy duplicates the original array and all its elements, creating independent objects. Choosing between swallow and deep copy is crucial based on whether you need to maintain original data integrity. Swallow, shallow clone or deep clone. Original original object and cloned object equal to reference object. In deep clone, original object, reference object, and clone object and reference object. Dynamic array explained. Dynamic array can resize themselves automatically when elements are added or removed. They provide flexibility over static arrays, which have fixed size determined at creation. This resizing is usually managed by underlying data structures, often use techniques like doubling the array size. Here we have some dynamic allocation of copy. We resize the array by double after one second, fourth, eighth. in the instructions. First, after one instruction, we can copy, and after second instruction, we copy both two. After four instruction, we can copy four. After eight instructions, we copy eight. Unused spaces are in white blank. In green blank, we used space at any indirect stages. Resizing an array. When an array reaches its capacity, a new larger array must be created to accommodate additional elements. The existing elements are copied over the new array, and the only array is discarded. This process can impute on performance cost if not managed properly, essential in the tight loops. Here the simple program of method resizing of our array. Public voids resize into new size. Open bracket, open flower bracket, int array temp array is equal to new temp, new size. For int initialize 0 and if count equal greater less than count on increment. Temp array I is equal to array my array I. Flower bracket close. My array is equal to temp array is equal to null. Practical implementation. Most programming languages offers built-in support for dynamic arrays such as Python list or Java list. Understanding how the languages handles resizing can lead to better performance in applications. It's important to be aware of underlying algorithms that manage dynamic resize for optimization. Here some example and some image. First, we can take a list. It's a 0 to 5 ratio. First, we initialize 10 after adding all elements. Array looks like this. And we added a new element size automatically grown by 50%. We are seeing below the two diagrams. Performance considerations. The average time complexity for adding an element to a dynamic array is uh, 0 or 1. However, the worst case scenario for designing can reach 0 of n when n is current size of the array. Considering the complexities is crucial for designing efficient algorithms and systems. Here are some data structures. Data structures have two different types of one is linear and another one is non-linear. In linear one, we can use arrays, linked list, stack, use. These are comes under linear data structures. And non-linear data structures are trees, graphs, tables, and sets. These are under non-linear data structures. Conclusion. Assigning arrays and managing dynamic sizes are crucial for effective programming practices. A solid understanding of those concepts helps prevent bugs and optimizing performance. Continuously learning and practicing with arrays will enhance your programming skills and significantly. In the above diagram, we can see the array list. We given the array list in the 0 to 5 and the index array index are shown in below and middle of the array is array elements we call as a array elements and thanks.